Hi everyone, and welcome back to my channel. Today we're going to be working through our fifth installment on our probability series, which is Venn diagrams. Venn diagrams are a graphical way of representing sample space and events. So as you can see by the two Venn diagrams I have on the screen at the moment, a Venn diagram is a rectangular box which represents the sample space, and that is everything or all the possibilities that could be in the events. And then we have our circles inside the rectangles which represent our events. Now our circles can either intersect or they cannot intersect, and we need to know the difference between when they do and when they don't. So if we're talking about the difference between mutually exclusive, complementary, and not mutually exclusive events, if I look at a mutually exclusive event, it means that they have nothing in common. All right, so you can see that those two circles are not intersecting, whereas a complementary event is similar to a mutually exclusive event, but then everything within the sample space is inside the two circles or the three circles, whichever number you have. So we have a mutually exclusive event, we have a complementary event, and then we have a not mutually exclusive event. And a not mutually exclusive event means that there is something in common. So you can see over here, I'm coloring it in purple. This not mutually exclusive event has something in common in that it's a 2 in this instance. If we look at the examples, we have the numbers 1 to 10 are written on cards and placed face down on a table. Event A would be finding a card with a value that is less than 5. So we have the numbers 1 to 10, so that would be our sample space. So our sample space are the numbers 1 to 10. Then we have two events occurring. The first event is a number less than 5. And the next event that's occurring is event B, which is a number greater than 5. All right, so it says represent this information in a Venn diagram. So to start, we're just going to quickly list our sample space. Remember, when you list numbers, curly brackets, semicolons in between. So we have the values 1, 2, 3, 4, 5, all the way to 10. All right, then we have event A. And event A is finding a card that has a value less than 5. So we have these values to choose from. We can pick a card between 1 to 10. So the numbers less than 5 in those cards are 1, 2, 3, and 4. Then event B is picking a number or a card that is greater than 5. So that would be 6, 7, 8, 9, and 10. All right, now when you're looking at this, you could pick out that a number that's not being selected at all would be the number 5. We're now going to represent this as a Venn diagram. So we're going to start by drawing our rectangular shape. So once we have our rectangle, we have to then decide whether our circles are going to intersect or our circles are not going to intersect. As you can see, in event A and event B, there's nothing that these two events have in common, which means that our circles will not intersect. So we have two circles that are not intersecting. So we've got our sample space, and we have event A, and we have event B occurring. All right, so event A, I'm simply going to take my values for event A, and I'm going to put it in event A's circle. So I have the values 1, 2, 3, and 4. Then I'm going to take event B. I have the numbers 6, 7, 8, 9, and 10. And I'm going to place them within my second circle, within my circle that is labeled event B. All right, now what you can notice is that there is no 5. The 5 hasn't been placed in either of the circles, but the 5 does belong within the sample space. So I'm going to place the 5 within the sample space, and now I've represented all of my information within the Venn diagram. Now I'm going to do an example of a complementary event. A dice is rolled and two events are recorded. Event E is rolling an even number and event O is rolling an odd number. Represent this information in a Venn diagram. So we have a dice. So for our sample space of a dice, we know that our sample space are the values 1 to 6. So I'm just going to jot those values down really quickly. Then event E is rolling an even number, and event O is rolling an odd number. So we have event E and we have event O. So event E is rolling an even number, so I have the numbers 2, 4, and 6. So I'm getting the even numbers from my sample space. So whatever my sample space is, whatever's available within my sample space, that's what I'm going to list. So I have 2, 4, and 6, and my odd numbers are 1, 3, and 5. Now, as you can see, within the even numbers and the odd numbers, I use up my full sample space. So I've used the value 1, 2, 3, 4, 5, and 6. So this is what we would call a complementary event. So to draw my Venn diagram, I'm going to start with my rectangle, and I'm going to label it my sample space. Are there any values that these two have in common? There aren't values that they have in common, which means that I'm going to have two separate circles. So the one circle will be called E for even, or for event E, and event O. So the event E, I'm going to put my values 2, 4, and 6, and for event O, 1, 3, and 5. And as you can see, there won't be anything left over for the sample space because I've now used up all my values, which is a little bit different to the previous one that I did where I was just working with mutually exclusive, where they also didn't have anything in common. However, there was still a value left over in the sample space, versus a complementary event where there's nothing left over in the sample space. All right, and then we get to a non-mutually exclusive event. So a dice is rolled. So I'm working with a dice again. So my sample space consists of the numbers 1 through 6. Now I have event A is rolling an even number again, but event B is rolling a prime number. All right, so I'm going to start by listing my sample space. So I have the values 1 to 6. 1, 2, 3, 4, 5, and 6. Then I have event A and I have event B. So from my sample space, from the values 1 through 6, event A is rolling an even number. So the even numbers between 1 to 6 are 2, 4, and 6. Then event B is rolling a prime number. So now again, working from the values 1 through 6, I'm going to list out my prime numbers, which are 2, 3, and 5. Those are my prime numbers within those values. Now, if I look at this, my event A and my event B, I can see that in fact there's a value that they share in common. There's a value that both of them have in common, and that's 2. So when I'm going to draw out my Venn diagram, I start with my rectangle, but now there's something that these two have in common, which means that my two circles are now in fact going to have something in common. They're going to have something that they share. So I have my sample space, I have event A, and I have event B. So A was rolling an even number, and event B was rolling a prime number. Now, whenever we have an intersection, whenever we have something where there's an intersection between the two, you're going to start in the intersection. So you can see that I started by first listing my intersection. So I put my 2 in there first. So now what I'm going to do is I'm going to gently cross out the 2 to make sure that everything is accounted for. All right, so 2 is the only thing that they share. So now I need to put the 4 and the 6 into a circle. So I put 4 and I put 6. I'm going to gently cross them out to make sure that I have everything accounted for. Then I have my 3 and my 5 that's left over for B's circle. So I put 3 and 5 into B's circle. So now I'm going to cancel it from my sample space, because by cancelling it from my sample space, I can now clearly see that there's a value that was missing that hasn't been into either of the circles. That's the value 1, because 1 is neither even nor a prime number. So 1 is going to go in my sample space, and that way I don't forget it. Now I just want to talk to you about the notation just really quickly. All right, if we look at this sample space that I've drawn here, so I have a sample space. That sample space consists of two events, event A and event B. Now these two events do in fact overlap. So they overlap, they have something in common, they intersect. Those are the different types of words that we would be using when we're talking about this section over here. So this section that I've just colored in purple is called the intersection. And that intersection is where these two circles or these two events overlap. They have something in common. Now, to work with this in notation, I would say that this is A and B. And as a mathematical notation, I could say A and then what looks like a little N, A and B. Now, if I try to remember which symbol goes with which, I can remember that and has an N in it, and then it kind of looks like a little N. Once we've spoken about the intersection is A and B. It's what they have in common. It's where they overlap. And then we have A or B. We have the union of the two events. And the union of the two events means everything that is happening within the event. So that's excluding what's happening in the sample space. So it's excluding anything that would be there. If I'm talking about what I've just highlighted in blue, that we would say is the union of two events. And that I would talk about as A or B. So it's everything within the two circles, and that we would talk about as A or B as notation. So another thing that I would say to remember it is union has a U in it, and that kind of looks like an upside down, not an upside down U, a right way up U. So that's the different notation that we would also be using, and that's what I'm going to be integrating into the next videos. See you soon.